All right, so a few people asked me to go over chapter 10 in the SL textbook where we're looking at triangles and circles. And we got to start with our good old friend SOHCAHTOA here, so I have that written down. Where if you've got a triangle and you've got if you've got a right triangle and you know this angle right here, you can set up sine for opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And the key thing is if you know the angle, you use the regular sine, cosine, and tangent buttons on your calculator. If you want the angle, you use the inverse. So keep that in mind, that anytime you know the angle, you're using regular SOHCAHTOA, and anytime you want to figure out an angle, you're going to have to use the inverse. But this only applies to right triangles. And a lot of times we have triangles that aren't right triangles, or maybe they aren't necessarily right triangles. So for example, if I have a triangle like this, where we don't know if it's a right triangle or not, there are still a couple rules that we can use. And one of those is the law of sines, okay? The law of sines is this idea that if I have three different angles, let's just label those A, B, and C, then the side lengths can be written A, B, and C. And I want you to notice that what I'm doing is whatever angle has a certain letter, I'm going to the opposite side of the triangle, the side of the triangle that doesn't touch that angle. And we get this rule where it's just that the sine of the angle A divided by the opposite side, which is also called A, is always the same as the sine of angle B divided by side B. And in fact, it's the same for all three of them. So a lot of times you see this three-sided equation like this. But really, in practice, you're only ever going to use two parts of it. And so the reason we write all three parts down is just to tell you that it's true for any of the sides and angles of the triangle. But really, when you're solving something, you're just going to set like one side and angle equal to another side and angle and solve for it. Okay? And you can prove that this is true. I'm not going to do the whole thing, but you can prove this is true by just splitting this triangle in half like this, because then that makes a right triangle. And if you call this unknown height x, or if you call it h, you can use your SOHCAHTOA, and you can see that sine of A is equal to opposite over hypotenuse. For this triangle on the left side, B is a hypotenuse. And you can see that sine of angle B is equal to opposite over hypotenuse. Well, if you solve this for x and you solve this for x, you get B sine A, and then over here you get A sine B, and you know that this is equal to x and this is equal to x. So set these equal to each other and divide, and you'll get back right there to law of sines. Okay? You're not going to be asked to prove it, but that's where the proof comes from. Okay? Similarly, if you've got a right triangle, or if you've got any triangle, you don't know if it's a right triangle or not, same sort of setup here. We've got an A angle, a B angle, and a C angle. You've got an A side, B side, and a C side. We can set up a formula called the law of cosines, or the cosine rule, where it's c squared equals a squared plus b squared. Well, that part is true for a right triangle. So then if it's a not right triangle, we go minus 2ab times the cosine of c. Okay, I'm not going to go through the proof of this, but the point here is that the law of cosines is something that also works anytime you have a triangle. You could use it on a right triangle if you want. It's just you'd rather use Pythagorean theorem or something else on that. Okay, same sort of idea. The letters are opposite of each other. So angle A is opposite of side length A, etc., etc. Now, here's a big piece of advice. Notice that when you're using the law of sines, there are two angles and two side lengths. So if you want to use the law of sines, if you have a problem, if there are those four different pieces of information, two angles, two side lengths, you need to know three of them for law of sines to help you. So you either need to know two angles at one side, or you need to know two sides and one angle. Otherwise, law of sines is not going to help you, because you need to have everything except for one unknown. Similarly, look at the law of cosines. Law of cosines has three sides and one angle. Four pieces of information in the formula, you need to know three of them. So if you know three sides, or if you only know two sides but you know one angle, then law of cosines can help you out. Okay, so you got to really think these two tools work on any triangle, but you need to know which one to use, and the way you know which one to use is based on the information that's given to you in the problem. Okay, great. Now, why don't we do a quick example where we're going to figure out if we want to use the law of sines or the law of cosines. All right, let me clear all this out here. So let's say that I've got a triangle, ABC, and they tell me that AB is 10, and they tell me that BC is 8, and they tell me that CA is 7. All right. On this one, think, am I going to use law of sines or am I going to use law of cosines? Law of sines has two angles and two sides. Law of cosines has three sides and one angle. Of those, you can hopefully see law of sines not going to help you here. So that's why this one would be an example of using law of cosines. Oops. Get out of the way. Okay. So C is 10 because that's opposite of the corner that's marked C. A is 8. B is 7. 2A is 8. B is 7. Cosine of C. Feel free to use a calculator on this. Let's see, what about 2 times 8 times 7? I don't know that off the top of my head. That's the broken calculator. So if I go 2 times 8 times 7, I get 112. 64 and 49 makes 113. So I got 100 equals 113 minus 112 cosine C. So I can take away 113. So negative 13 is negative 112 cosine C. Divide 13 by 112. And then here, I don't know the angle, so I'm going to use the inverse cosine. So you hit the blue button, you hit second cosine, use the answer that you had before, or type the fraction in. Try not to use the decimal. So we know that angle C is approximately 83.33 degrees. That's approximately equal to angle C. Now that we know one of the angles, we could use law of sines to figure out another angle. So for example, I could figure out angle B by saying sine of angle B over 7 is equal to sine of angle C, 83.31, or sorry, 0.33, can't read my own handwriting, angle C over 7. If you solve for angle B, you can see that what you're going to do is sine divided by 10, because that's right here, sine divided by 10, sine 83.3 divided by 10, and then multiply that by 7. So you can see the steps on the calculator there. Now that answer is what sine of B is equal to. So sine of B is equal to this nasty decimal, 0.695. So I do inverse sine of that answer, and that gives me the second angle. So B is approximately 44.05. As a good reminder, the three angles all add up to 180 degrees. So I can go 180 minus my sine answer, minus my cosine answer, and I get the other angle, 52.62. Okay, great. So there's one other thing I want to show you here, which is the angle, or not the angle, the area of a triangle. So a lot of people are familiar with just saying 1/2 times base times height, but this is only if the base is perpendicular to the height. That doesn't work if you've got a triangle like this. You can't do 1/2 times this times this. That doesn't make sense. It only works if your base and your height are perpendicular. So what do? If you have a triangle like this, you can, just like we did with the sine proof, you can cut it up into 2 right triangles. And let's call this side length, or angle C, because it's opposite of side length C. And if you think about angle C, I could do this. I could say that sine of angle C is equal to the height of the triangle divided by side length A, which means that the height of the triangle is A times sine of C, which means now I know a base and I know a height, so I have a formula that works for every triangle. 1/2 AB sine C. So use that formula anytime you have a triangle, A and B, and C is just the angle in between them. Okay, so here in this video I just kind of covered triangle stuff. I'll make a separate video where I look at circles and sectors and arcs.